All right, thank you very much. I hope everybody's having a great conference, and certainly thank you to NUR and all the organizers at AngularUP. Happy to be here. So far, it's been a great conference, and so I'm looking forward to kind of sharing with you a little bit about what I've learned about Angular template type checking. I'm a Google developer expert in Angular and web technologies, and I also really enjoy traveling. So I just wanted to share a couple pictures with you kind of as we meet each other virtually here. Here I am hiking in Norway. Kind of see the fjord in the background behind me. It was a really great hike. I think it was about 9 kilometers round trip. And then my wife and I in Spain. And as I already mentioned earlier, I'm currently residing in Portland, Oregon in the United States. But enough about me. Let's go ahead and dive into what we're going to be talking about today with Angular template type checking. The first thing we need to do is we need to talk about Ivy. And I know Martina just did a really great job of talking about Ivy and higher order components and some of the enablement of Ivy. But we need to quickly mention that because Ivy also comes into play with Angular template type checking. We're then going to look at a research study. I'm going to share with you kind of a research study that was done by Microsoft Research. I'm going to talk about the 3 different modes that are available that you can configure with Angular and template type checking. I'm going to then take a look and break this all down for you in an example. And then after that, we'll actually dive into a demo. And then finally, we're going to take a look at a template or type coercion and what that involves. So of course, if you haven't heard by now, and of course, Martina just did a really nice job for us talking about Ivy. Ivy is the new compilation and rendering engine for Angular, and it was shipped in version 9 by default. And so everything that I'm talking about in this talk for the next couple of minutes as we share this time together is geared towards those that are on Angular version 9 and higher and with Ivy enabled. So if you're not on Angular version 9 or higher, you want to go ahead and get there using NGUPdate. Get to the latest version, stay up to date and current if you can, and make sure that you have Ivy enabled to get some of these benefits. Okay, now let's talk about this research study. And I think this is really interesting. So the name of the research study was called To Type or Not to Type, Quantifying Detectable Bugs in JavaScript. And it was performed by Microsoft Research in conjunction with the University College London. And what they did is they went out to GitHub and they looked at public JavaScript repositories, right? So they went out, looked at all the public JavaScript repositories, and then they looked at closed issues. So they said, okay, let's look at the issues that have been closed. So there was a bug and it was closed, and let's see like what was the problem with that issue, what had to happen in order to close that issue. And what they found is that 15% of those closed issues could have been caught ahead of time with type checking and using something like TypeScript. So think about that. 15% of issues in public JavaScript repositories should never have been an issue in theory if we were using type checking in those projects. And of course, this is directly related to TypeScript. And I think the study was certainly around that. And you can go read it if you like. It's a very interesting paper. But I do think that this has, this correlates strongly to Angular and template type checking. And we'll get more into this, and I'll show you some of the benefits of template type checking in Angular with version 9 and higher. And hopefully you'll start to see, oh, okay, now I'm getting how I can start catching some of these errors in my application ahead of time before I submit my PR and it goes through CI/CD or maybe even into production. Now let's talk about the 3 modes that you can configure for Angular and template type checking. So you've got basic mode, full mode, and strict mode. And as you might imagine, basic mode is does the least amount of type checking. Full mode does additional type checking for us, and strict mode is full on and does as much type checking that is capable in Angular today. How do we enable these different modes? Well, you're going to go to your tsconfig.json file, and in the Angular compiler options section, you're going to set full template type check to false. So that is going to turn off full template type checking, and now you're in basic mode. And so now you've got the least amount of type checking happening in your Angular templates. If we set this flag to true, now you're in full mode. So now we've kind of ratcheted things up and we've got some additional type checking in our application. If you want to go to strict mode, You don't need the other flag. You're just going to use a new flag or a new property in this configuration called strict templates, and go ahead and set that to true, and that'll override whatever you have set in that other flag. And so now your application is in strict mode. Okay, let's take a look at an example, and then I'm going to dive into a demo, and then we'll get into the setter coercion. So in this first example, basically I've got an application that's displaying a bunch of films. So I've got Brian's films, and I'm iterating over some film objects and outputting out a list. Let's take a look at the code for this. So here's my parent component, if you will, that has the app films component in its template. And so we can see that app films has an input binding for a films property, and it's expecting that to be an array of film objects. It also has a films change output emitter, and that is going to pass along an event object, and it's going to invoke the onFilmsChange method. Let's take a look at the component, the TypeScript for the component. And here we can see that I've got some magical data object that's got a person in it, and the person object has a property called films that we're going to be able to access the films for a particular person or actor or actress. I also have my onFilmsChange method defined, and you can see here that it's expecting an array of film objects. Now let's take a look at that child component. So let's take a look and focus here on the template for the child component. Now I'm using an ng container here, but this could be a div or anything else. That's not really important, so don't get hung up on that. But what is important is that I'm using the ng structural directive to iterate over the array of film objects. And then I'm outputting the title and then the release date. And then I'm piping that release date into the date pipe. Now let's take a look at that component's code. And here's my input for my array of film objects. And here's my output, my event emitter, that is emitting an array of film objects. But now that we've kind of set the stage, let's take a look at how template type checking comes into play for these kind of various scenarios. So here's that parent component. We have app films, and I'm binding down to the films property, and I'm setting that equal to data.person.films. And we got the films change output binding, and we're invoking the onFilmsChange method in my component. So notice here I've got basic, full, and strict up top, and a green check is going to indicate that we're going to get template type checking. So the first thing that the Angular compiler is going to do is going to say, okay, well, data, do we have a property in the class called data? And basic, full, and strict mode are all going to check for this property. And if it doesn't exist, you're going to see an error when you try to compile your application in your terminal or in your console. The next thing that's going to happen is the compiler is going to go another step further and say, okay, well, data, great, that's a class property. Now, is data an object, and does it have a person property? Again, all three modes are going to check for this. This is good. We're going to go even further and say, is data.person an object, and does it have a films property? All three modes are got you covered here. So it's going to check for these properties values. But this is where things start to kind of deviate and get a little interesting for us. Now, what we're going to do is the Angular compiler is going to say, okay, well, is that films property, is that actually assignable to the films input? In other words, do the types match up? Is the films property on the person object an array of films? The type is an array of films. And does that correlate to the films input, also expecting an array of film objects? Here we can see that basic mode, we're not covered, right? So if the types don't match up, we don't know during compile time. We could ship that code to runtime. We might get a runtime exception that basically says whatever, it got some other object and properties were not, undefined or something like that. Of course, full and strict mode are going to check for this. This is where it gets even more interesting, is the $event object. So in basic and full mode, $event is any. And as we know as Angular developers, and we write TypeScript, any is any. And so it could be anything. And so we don't really know what $event is. But in strict mode, we know that $event is a type. Actually, that should be an array of film objects. It's an array of film objects, and we know that my method onFilmsChange is expecting an array of film objects. And if those types don't match up at compile time, we're going to know about it. Now let's take a look at that child component. And the important part about this is anything inside of an NG4 structural directive is called an embedded view. And don't get hung up on that too much, but basically an embedded view is kind of a view that's inside that as it's iterating over these film objects and it's generating out the HTML for us. And the important part to know is that in basic mode, everything inside of an embedded view is not type checked. So once I do an NG4, if I'm accessing a property in here, like the film property or the fields property of the film object, in basic mode, we're not going to get any help. We could ship that to production and see runtime exceptions. However, if I'm in full or strict mode, we are going to get type checking within an embedded view. So let's break that down a little bit further. First, the compiler is going to say, okay, is fields a property of the film object? Yes, it is. Good. In full and strict mode, we're going to check for the existence of that property. Next, we're going to go even further and we're going to say, okay, well, is film.fields an object? And does it have a title property? And this is where we again start to see some differences between the different modes. Full mode is only going to check for that first property to exist on the film object, that fields property, but it's not going to go any further along and verify the existence of that property and the type. This is where strict mode is going to check that film.fields is an object with a title property. Again, same thing. Does the release date, does that property exist? And then finally, is the release date a string? Because the date pipe is expecting, in the transform method of the date pipe, is expecting the type to be string. So in strict mode, where it's actually going to check that when you're piping a value into a pipe in your template, it's going to check that those types match up. A date pipe actually might accept a number or a string, but let's say that release date was an object of some sort. At compile time, it would say, hey, you can't use release date here because these types don't match up and you can't send this to the date pipe. All right, good. Let's take a look at an example. And I want to show you a quick app that I wrote. Ooh. All right. So here we've got an application, maybe some sort of like banking application of some sort where it's showing some of my customers. And we've got name, city, state, zip. You can see already I've got a problem. State and zip is not displaying. And according to UX, I was supposed to display the amount in their account and kind of the account name. So we've got some problems here. But the odd part is if I come over to, my running application, I just ran npm start. Let me boost this up a little bit for us. I just ran npm start and it said everything compiled successfully, but clearly everything is not good, right? So there's some missing parts to my application. So let's come over here and let's take a look over at the component. The first thing you can see here is my IDE is going to pick this up for me, but I've got a typo in this embedded template. So I'm currently in basic mode. I should have showed you that first, sorry. Let me bump this up a bit. So you can see here that right now I don't have anything defined. So I'm going to default into basic mode. And so in basic mode, we're not going to get any sort of type checking in this embedded view. Let's go ahead and switch over to full mode. So I'm going to comment this out and we're going to set the strict templates to true. And then I need to go ahead and restart the development server and compile. Okay, good. This is a good thing. We got some errors. I know errors are usually not good, but we're starting to see we've got some problems here that we need to fix. First of all, we've got this undefined is not assignable to account. Let's go ahead and take a look at that. Let's see what's going on with that. So I'll come back over to my app component. Oh, it looks like I made a mistake here. I'm actually finding the order for a customer, not the account. Aha. So let's just fix that. Bring that in. And let's go ahead and go to the next one here. And we can see it triggered, it said, oh, custom does not exist on the type app component. We knew that was coming. So let's go ahead. This is supposed to be customer. All right. And let's save this and let's see what happens. All right, so now you can see that address does not exist on customer. So it looks like we've got another problem to fix. We knew that. And postal code does not exist either. So we've got to fix that as well. So let's just do that. Kind of knew that was coming. And postal code, this is supposed to be zip. So let's kill that and let's try starting to back up again. All right, so now we're getting undefined, can't be assigned to account or null. And it looks like we've also got, this is the kind of the same error. So we've got a problem here still with the fact that this is returning this accounts.find. So let me come over here and let's just do, let's see, we want this to be or null. So we need to just do some coercion here and say, okay, if it's undefined, let's just let it go to null. All right, good. So everything's passing for us. If we come over to our application, you can see here now that we are getting our application looks like it's supposed to look like. But there's one other thing that I want to show you real quick in our demo application. Let's go back over here and I'd actually set, oops, sorry, I skipped ahead and I set strict templates to true. Sorry about that. We should have gone to basic or to full mode first, but we're actually in strict mode here. So we can see that's how it was catching some of that makes sense now, because when I was doing the binding down here, if I was binding this, the input binding would not have actually verified. But that's all right. Let's go ahead and skip. I want to show you one additional thing here. And I want to look at this amount change event emitter. So I want to kind of prove to you that $event is no longer going to be any when I'm in strict mode. And so if I come over to my application, here's my binding. So I've got this ng model change, and I'm emitting out to the amount change event emitter. I'm invoking that emit method. But the interesting part here is I actually have type number. So the type coming here should actually be a number value. So let's come over here and let's change this to number. And then let's run our application. Let's just start it up again. And what we can see already here is that an argument of type number is not assignable to the parameter of type string. And the reason for that is the event emitter, that event $event is now actually a number. So if we come back over here, if we hover over, it's a little funky there. Okay, we can see that amount change $event is no longer any, it's actually a number. And so I need to fix my method here to actually accept a number. And now everything should line up. I'm in strict mode. I fixed a bunch of bugs in my template that were kind of leaking through to runtime, if you will. I could have made it out to production if it didn't get caught by QA. But with strict mode, I'm able to catch a lot of these additional potential problems right during compile time. All right, finally, let me finish up real quick with input setter coercion. And so what I want to show you here is I've got an example of a button component. And the back property for this button component is currently accepting a Boolean value. So I've got a setter for back, the value is Boolean, and I've got kind of a getter and a private method. Let's take a look at an implementation of this. So here I've got my app button, and I may want to toggle whether this button has like a back arrow on it, right? And so what I want to do as a developer probably is just say, yeah, I want this to be a back button. Just go ahead and apply a back button to this. So I write out the code as follows. But what we need to understand is when you write just an attribute or a binding like that, what's really happening is under the hood, kind of, it's binding that to just an empty string. And if you try to use this with strict template type checking, you're going to get an error saying you can't bind, the type string can't be set to the type Boolean that the input property is expecting. And so what we want to do is we want to coerce this value. And so you can see here, I changed my setter where I'm checking, hey, if the value is just an empty string, good. Otherwise, use this Boolean value that's provided. But the key takeaway here is down at the bottom. Notice this new static property that I've defined. And what I'm doing is I'm telling the Angular compiler that I want to override the input setter type of the type of the input setter. And so what I'm saying here is let's go ahead and have NGUPEx input type, and that's kind of a special string that you need to use, followed by an underscore, and then whatever the name of the property is. So here I'm setting that input type to be a Boolean or an empty string, and now the Angular compiler is going to be happy, and we're kind of coercing that type, if you will. The last thing I want to quickly mention is how do you get to strict mode, right? You might be thinking, hey, this is great. I want to do this, but how do I actually get there? And so the way you get there is first start by turning on full mode, assess the level of effort. In your sprint planning, go ahead and use that assessment to plan out how you're going to actually get to full mode, and then repeat to get to strict mode. And that's the best way that you can get there. And then once you're on strict mode, stay there. The key takeaway here that I want you to learn is this 15% number. Imagine 15% bugs, 15% regressions, 15%, maybe 15% more time to develop new features, or maybe 15% more time to go hang out at the beach. You do you. With that, thank you very much for attending my talk. You can follow me on Twitter at Brian_Love. I blog on my blog at Brian F. Love. I just started a new way to learn in public on lookout.dev, and my company is liveloveapp.com. Thank you very much.